Okay, morning guys. Just following on from our class on Thursday. So during the class on Thursday we talked about the rotation of the Earth. We talked about how the Earth rotates around the sun, how that gives us the rotation of the Earth on its own axis gives us day and night because half of it is pointing towards the sun and half of it is pointing away. And then the revolving of the Earth around the sun coupled with its tilted axis gives you the seasons. So we watched that video there on the seasons. We talked about this diagram, which was how we relate the sun, the Earth, and the moon. So that's an important one. Now, why we only see one side of the moon. This is the link that I forgot to put in. So let's have a look at this, okay? I'm going to talk over it because there's no sound. Okay, so do we always see one side of the moon? So here's the moon with no rotation whatsoever, okay? Sorry. So there it is moving around with no rotation of the actual moon itself. Okay? And in that situation, if you were standing on Earth looking at it, we would have seen all sides of the moon. Okay? So now what they're going to do is they're going to put a rotation onto it. Okay? So the moon is now spinning. Now, I just want to go back a little bit because I want to count these rotations as best I can. Okay, so, hang on. Pause it for a second. Okay, so I'm going to count it, the red bit, which is supposed to represent the side of the moon we see. The kind of white bit is representing the dark side of the moon. So we're going to watch the rotations of the moon, okay? Okay. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay? So what they did there was they got the moon rotating, but they rotated it 8 times. So it managed to turn itself 8 times in the time it made one go around the Earth. And we know that's not the case. We know that it takes 29.5 days for it to turn itself, and it takes 29.5 days to go around here. Okay? So in that last little animation, you would see all sides of the moon because it's turning around so many times, but that's not what happens in reality. In reality, the moon turns much, much slower. Okay, so watch what happens when they put the correct rotation on the moon. So now it's turned a quarter. Now it's rotated half. It's turned 3/4. And there's your full rotation. Okay, so when this moon only turns once in the time it goes around the Earth, then this red bit is always facing the Earth, and that's why it looks as if it doesn't turn, and that's why we only see one side of the moon. Okay, so it's all to do with the fact that it takes 29.5 days for this to turn around, and it takes 29.5 days for it to get all the way around there. So when it is a quarter of the way through its way around Earth, it's also a quarter of the way through a turn. When it's halfway around the Earth, it's halfway through a turn. Okay, so that red bit is always pointing towards the Earth. Okay, so that is, where am I gone? That is that video I just wanted to show you to explain why we only see one side of the moon. We then talked about the stages of the moon. It's a cyclical thing, so you have your new moon and then you go into your waxing stages. So if you're waxing crescent, where it's a very, very thin sliver of light, and it's waxing, which means it's getting bigger, you get then to when half of the moon is illuminated, and we call that the first quarter. It will continue to get wider and wider, and when you have more than half illuminated, it's in what's called a gibbous shape, and again it's waxing, so it's continuing to grow towards a full moon. You then reach full moon, and then you go through those stages but in reverse. So you go back to waxing gibbous, but the other side of the moon is bright and dark, whichever, like, so that's the opposite sides. Same with your third quarter or your last quarter. So you've half the moon illuminated again, same as in the first quarter, but it's the other half. And then you've your waning crescent, which is where you have the crescent bit of the moon, but it's getting thinner this time because it's waning. And then you're moving back into the cycle again, back to your new moon. Okay, so you need to know those diagrams and which side of the moon is dark and which side is bright. And there's a link there to that website I used to go through the different phases, okay? So what I want to do today are the eclipses, okay? I have videos on these because it's nice, I think, to be able to see the videos, but what you need to know is the arrangement, I suppose, okay? So in a solar eclipse, the moon passes between the sun and the earth. So in a solar eclipse, the moon is in the moon is in the middle. Okay? So you have the moon down here passing in the middle. Like we said about all the rays that come from the sun, the ones that strike the back of the moon are lost. So you end up with shadow, and that casts a shadow on the earth. And then that's what we see, okay? So I'll show you this video. We'll just watch this.
A solar eclipse happens when a new moon moves between the Earth and the Sun, blocking some or all of the Sun's rays from reaching the Earth. By cosmic chance, even though the Sun is 400 times wider than the Moon, it's also 400 times farther away. Therefore, the two objects appear the same size in our sky. Astronomers are able to predict eclipses because the Earth and Moon have very predictable orbits. Why then isn't there an eclipse every month? The Moon's orbit is usually tilted a few degrees north or south in relation to the Earth. When the Moon does eclipse the Sun, it casts two types of shadows on Earth: a smaller, darker shadow known as the umbra, and a larger shadow known as the penumbra. There are four types of solar eclipses. The first and most spectacular is a total eclipse, when the Moon completely covers the Sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the Moon passes in front of the Sun off-center, never fully covering its surface. Third, an annular eclipse occurs when...
Okay, so there's more than enough information there. So you saw that the moon gets in the way, essentially, of the sun's light, and you get these, you can kind of see the two shadows in this picture. So the dark shadow is called the umbra, or the umbral shadow, and then the lighter shadow is called the penumbra. So to see the total eclipse, you have to be standing in the umbra. Okay, now because obviously these are all moving parts, the umbra moves across the earth while the sun and the moon are moving. So you have to be within that umbra somewhere on the earth, essentially, to see a total eclipse. And then if you're in the penumbra, you see a partial eclipse. So it won't go totally dark, but you will notice it getting a lot darker than it was 5 minutes ago. Okay, so that is your solar eclipse. And then your lunar eclipse. So again, you just need to know these in terms of what gets in the way where. So in a lunar eclipse, the Earth is the one that goes in the middle. Okay, so in a lunar eclipse, the Earth is in the middle. So it's the Earth that's blocking the sun from reaching the moon. Okay, and we'll watch this one.
For just $67, you can make as many videos as you want, and you never need to pick up a camera or use any. A lunar eclipse happens when the Earth blocks some or all of the sun's direct light from reaching the moon. This cosmic event only takes place during a full moon, which happens once every 29.5 days, or the length of one full orbit of the moon around the Earth. So why don't we have an eclipse every month? The moon's orbit is tilted a few degrees in relation to the Earth, so the Earth, moon, and sun don't always align. When the Earth does eclipse the sun, it casts two types of shadows on the moon. A larger shadow, known as the penumbra, and a smaller, darker shadow, known as the umbra. There are three types of lunar eclipses. The first is a total lunar eclipse, when the sun, moon, and Earth are in perfect alignment and the moon falls within the Earth's umbral shadow. Total lunar eclipses are the most striking of the three types because they turn the moon a sunset red. While shorter blue wavelengths of light are scattered outward by the Earth's atmosphere, longer red wavelengths are refracted or bent inward toward the moon, making it appear red. The brightness of the moon's red glow depends upon how much.
Okay, so again, you feel free to watch them, but that's essentially what you need to know. Okay, so with eclipses, you need to know that a solar eclipse is when the moon passes in between the sun and the Earth, so the moon blocks the sun's light, and that creates shadows on the Earth. If you were within the umbral shadow or the path of totality, you will see totality. You are in that really dark shadow, so you will see almost complete darkness. It will be like it has become nighttime. If you are within the penumbral shadow, which is the not so dark shadow on the outside, then you won't get complete darkness. You'll more get like a dimming of your daylight. In a lunar eclipse where the Earth is in the middle, you have the sun's rays arriving, trying to pass through the Earth, can't. So you create the same two shadows, the umbra and the penumbra, and then the sun or the moon, passes into one of those shadows. Okay, they spoke there about when it's in the umbra and you get the red glow, and you can have it pass into the penumbra as well, the same as the Earth, but it doesn't. From your point of view, it doesn't make a difference. Okay, all you need to know is that's the Earth blocking the sun's rays. Okay, so that is actually the end of the chapter. So I'll throw your homework into the homework journal. It's an exam or 2 exam paper questions, I think, on this chapter, and that's going to be due for Thursday. Is that okay? So that's that chapter done. So take down your notes and give your homework a go, and make sure it is uploaded to OneNote by 9 a.m. on Thursday morning, please. Thank you.